A pontoon is to be made in the shape that's shown. It's designed by rotating this graph 1 minus x squared over 16, and we're going from -4 to +4. We are going around the x-axis, all right, around the x-axis, where x and y are measured in feet. So because we're going around the x-axis, then this function needs to be in terms of x, meaning your x is what your dependent variable is. So we want to find the volume of the pontoon. If we did disk method, right, which is what it's kind of set up for, the x-axis is y equals 0. My function is in y equals. So I'm not going to look at shell method here. This is what I want it to be in. And in this case, I'm going to say, I'm going to do disk method. Because for shell method, if I'm going around the x-axis, then it's going to flip it, right? I need it to solve the other way. I'm not going to solve this a different way. If this is x-axis and it's in terms of y equals x, then I'm going to leave it that way and do disk. If this was x-axis and it was in terms of x equals y, then I'm going to do shell, okay? And so because it's set up this way and it would be a really big pain to fix it, I am going to leave it alone and do pi r squared. Pi r squared is much easier. And so the biggest deal here in any of these is just figuring out which method is going to be the easiest method. And so for this one, I'm going to do this method, right? Because I already have it set up that way. There is no hole that's created, so it's not even a difficult one. I'm going around an axis, so I don't have to shift it. Like there's nothing in this that makes a disk method difficult. So there's no reason to move it around. So this is one example of looking at what I have and saying, okay, I'm going around the x-axis. This is a horizontal rotation. It's already set up for a disk to do it. Leave it alone. Now, there are going to be times when I say it's already set up for a disk, but it's a really easy transition to shell, and maybe shell is easier, right? But in this case, we don't have an easy transition. And so I'm going to leave it alone, and I'm going to do exactly what it gave me here. And hopefully you know how to do this. We're not going to go through the mechanics of it. Foil that guy. All right. So anytime you have the number one problem that I see with your disk method, because you're squaring the function, is people don't square this correctly. So this is a foiling. You want to set it up twice and you want to foil it. But then it's just straight antiderivative. Add an exponent, divide by your new exponent. That's all you're doing here. Plug in a -4, plug in a +4. So the rest of it is the same antiderivative that we've always done. The most difficult part of this section is recognizing which method I should use. Should I use disk? Should I use shell? What's my easiest method? Let's look at example 5. All right. Find the volume of the solid formed by revolving this region by the graphs of x squared plus x plus 1 and 1. So I have two graphs that are set up with y equals. And I am going around the line x equals 2. All right. The line x equals 2 is a vertical, right? And so this one is actually set up the other way. This is actually set up for a shell. Do you see that? So this is actually set up a vertical, but with y equals. All right. So remember, the shell is opposite of my disk. When I did the one above it, I was revolving around the x-axis, and that's y equals 0, right? And x-axis is a horizontal, so it was y equals 0, and my functions were y equals. That is disk. Y equals 0, and function is y. This is x equals a line, and I am revolving it with a y equals function. So this is actually set up for shell. And again, look at that function. X cubed plus x plus 1. Do you want to rewrite the function? Because I don't want to rewrite that function. So I'm going to leave this as a shell. The difference here is that my r is going to be a little different, and I have the area between two curves. So I'm going to go way back to the original. What did I do to find the area of two curves? So I have two curves here. I have to find the area between them. So my h, my height, is going to be the area between the two. I have to subtract those two functions. The other thing I have going on is I'm revolving around the line x equals 2. So my r is no longer the distance from 0 to x, it's the distance from 2 to x. Okay, so my r is also different. Does that make sense? All right, so I'm going to use my 2 pi. I am going to go from the 0 to 1, because I have, if I were to plug in, so I have a 1 here. I already know that's a 1, right? And they haven't told me like where else I'm going. So I'm going to start from this axis here to this axis here. Go here. If I were to set those equal to each other, I would get a 0. X cubed plus x equals 0. If I were to set these equal to each other to see where they cross, okay? So they've already given me this right here, x equals 1. But if I were to set them equal to see where they cross again, they're going to cross at 0, right? So if I set those two functions equal to each other, x cubed plus x plus 1 equals 1, I'm going to end up with x cubed plus x equals 0. So my other option is that x equals 0, right? And so that's going to be my lower bound, all right? Now I need to figure out my r. My r is how far away I am from what I'm rotating, okay? Normally I would say, okay, I'm at 0 because that's what I've been rotating around, and I just go to x. So normally my r is just x. From 0 to x is the distance x, right? But now I'm rotating around this 2. So I'm going to say, well, if x is here, how do I know how far I am from here to here? Well, how do you do that in any distance? If this was 1.5 and this was 2, how would you figure out how far away they are? 2 minus 1.5, right? Or whatever it might be. So I have x, that's where I'm going to. How do I figure out how far away from 2x is? Well, my r is going to be 2 minus x, okay? That's my r. My h, my h is going to now be the distance between two functions. So normally my h would just be the function, right? Because I'm assuming I'm going all the way to the axis. But they've given me two functions. They've given me the function y equals 1, which is right here, and this x cubed function. So to figure out my h, I'm actually just going in between these two. Again, how do I figure out what's in between two things? I subtract them. So my h is now going to be the distance between these two functions. That's my h. So I'm going to have to take this function and subtract this function to figure out what my h is. So I'm going to say, well, my h is going to be x cubed plus x plus 1 minus my y equals 1. That's the distance between those two. So my r is now a distance between two things, and my h is now a distance between two things. And then I just have dx. I'm going to simplify this. So this is 2 minus x. This ends up being x cubed plus x, right? I'm telling you the easiest thing to do here is to FOIL, all right? It's definitely going to make your life easier. So we have 2x cubed plus 2x minus x to the 4th minus x squared, right? I just FOILed. That's all I did. And they put it in standard form. So they said negative x to the 4th plus 2x cubed minus x squared plus 2x, right? So they just put it in standard form. And then they did the antiderivative here. And then we have a really easy, again, at this point, I shouldn't have to walk you through. We're adding one and dividing by my new one. So at this point, hopefully you know how to do that from 0 to 1. Plug it in, multiply by 2 pi, right? And you end up with something, I think they said 29 pi over 15. You're just plugging in a 1, subtract, this is a 0, so that's easy. And then multiply by 2 pi.